Looking at the information that's been given to me, I have an angle, I have a side length opposite the angle, and then another side length. Right? Typically when we do these questions, they're all going to be drawn the same. Okay? So you're going to draw whatever they say, angle P, and then you're going to have side length Q is going to be here. Q is going to equal 35.4. I'm looking for the H, the height of the triangle, and then it tells me side length P. And again, these triangles are, like these diagrams are never really going to be perfect because you don't know how tall it is until after you start doing the work, right? So I'm after H to figure out whether or not there's going to be a triangle formed. Everybody okay? And again, I think with the actual application questions like this, when there's actual numbers in the question, it's a little bit easier to contextualize the actual situations that we saw on the first page, because you actually have numbers to compare with one another instead of inequalities that you're looking at, which, fair enough, most people are not great at looking at, including myself, and coming up with conclusions. But it's a lot easier when you actually have numbers that you can compare side by side. Okay, so same work. I need you to figure out the height of that triangle and then decide whether or not P is going to touch the bottom. Right, so the first thing is we're just going to decide that H is going to be Q sine theta, and so H is going to equal 35.4 sine, oh sorry, I didn't draw my angle in there, 42.6. Sine law. Well, I already explained why though, right? It's up top. If I remember this little blue triangle, H is opposite, and that other piece of information is the hypotenuse, which is so, right? So sine. That's where that's come from. Okay, we should see that the height of that triangle is going to be 24 centimeters. Does everybody confirm that? Okay, we need to decide now, what situation are we in from the front? Is there a triangle? Is there one triangle? Are there two triangles? That's a decision we need to make. So to make that decision, I'm making a comparison between this side length, the height I just found, and side length Q. It looks like side length P is larger than H, but side length P is also less than Q. So which situation am I in? I get two triangles in that situation, right? Because that side length P, I can put either on the right side of the height or on the left side of the height and create two triangles. So let's draw triangle 1. Okay, so it wants us to solve. Which means how many answers am I going to have on each of these? How many pieces of information are required or on a piece on a triangle? 6. How many triangles am I going to draw? 2. So there should be, albeit some of the information is the same, we should be able to tell me 12 pieces of information here between the 2 triangles. Some of it's shared, not going to change, but there are maybe 2 that are going to change the angles, right? And so that's what I'm after. I want to be able to answer all 6 pieces of information for both triangles. So that's what we're going to do here. We're going to do this work twice, right? Once for the situation where the side length P is on the right side of the height, and one triangle where the side length P is on the left side of the height. And figuring out all information in both of those triangles. So that's what we're going to do with we're doing the one on the right first, as depicted by the diagram. Okay, so what information do you think I need out of that triangle?
Yes.
Owen?
I would say angle of the top or whatever.
Yeah, I'm gonna need that angle at the top. What else?
We already have Q. The angle Q is what.
You need angle Q, and what else?
And side length R.
And side length R. In order to answer or solve the question, if you will, or solve the triangle, I need all that information. Okay, so the first thing I can do is I can go sine of 42.6 over 25.6 is equal to, what do you want to do? Yeah, I think so. Right, I could get that pink component, the angle Q, right, by going sine of Q over 35.4. So I can cross multiply and solve, right? So when I cross multiply and solve, I get 35.4 sine of 42.6 is equal to 25.6 sine of Q. And so if I go through all of this process here, I'm going to find out that angle Q, when I go to solve, should be 69.4 degrees. So now I can put that on my diagram. So I've got 2 more pieces of information to find. What could I do now?
180 minus 42.6.
Yeah, I could find angle R by going 180 minus the other 2 angles, so 42.6 minus 69.4. That makes angle R what? Okay. That's good. So now we know angle R. That's the angle up top. That's going to be well, I'll just call it 68. 68 degrees. Okay. And one more piece of information. And that's that red component on the bottom, so that bottom side length. I use sine law again, right? What information am I going to use though? Ideally, the stuff that's been given to you in the question, just in case you made a mistake, right? So I would just use sine of 42.6 over 25.6 again, right? You might have to use one piece of, I guess if you made a mistake anywhere, it's going to cost you, but I would just use the information that's been given to you in the question. So I'm going to go the sine, so that's step 2. Step 3 now is to find side length R. So the sine of 42.6 over 25.6 has to equal the sine of 68, which is angle R, over R. And if you use sine law to solve, you should find that side length R will be 35.1. You know what else we're gonna do? We're gonna denote it R1. You all see that I'm subscripting these as Q1 and R1, and I suppose this could be angle R1 too, right? So I have a little list here. R1, the information that's gonna change from one triangle to the next is that blue angle. I'm gonna subscript that angle 1, or R1, angle R1, 68 degrees. What was the other one? Q1 was 69.4 degrees, and R1 is going to be 35.1 centimeters. So who thinks we're done now? We all done? You have to do the other triangle. What's the other triangle look like? The other triangle looks like this, where I've got point P, R, but this time, instead of the arm going down this way, where's it gonna go? All right, I'll draw this horizontal first. So it's the same three pieces of information you're looking for this time, except it's changed, right? So you just gotta solve, you're doing the exact same work over again, right? Because the blue angle is changed at the top. So that's not a highlighter. The blue angle is changed at the top. Q2, or the angle Q is changed, and side length R has changed. So you gotta redo all this work. It's the exact same work, it's not hard. It's just annoying because you gotta do it twice. Because there's two triangles. Right? So angle P again, same angle P from before, that's 42.6. I might make this bigger in one sec so you guys can all see it too. Okay, so angle P is going to be 42.6 again. Q's changed. This side length's the same. So I suppose three pieces of information aren't going to change, and three of them are. So now you just gotta do the same work and solve for those same three pieces of information: the blue piece, the pink piece, and the red piece. Okay, so, and then pretty much in the same order too, right? Like I think all the thinking's done. You do all the thinking in the first part. So I'm just gonna do sine law, sine of P, sine of 42.6 over 25.6 has to equal the sine of Q2 over 35.4. When I do that work, I should get that angle Q2. When you do that work too, I should see that that angle should be what?
69.4.
Say that again?
69.4.
For Q2?
Because it's the same stuff.
It's not the same angle though.
Yeah, I know, but it should be different, but it looks the same as the other one.
Okay, to Owen's point, I actually don't think we're doing the same work because I just realized this. Dylan?
Wouldn't it be 180 minus like that?
Yeah. So here, look, if I extend this side length out, this angle here should be what?
69.
69.4.
Yeah.
Which would make angle Q2. I actually don't need to do this work if you're clever enough. It's not that it won't work, it's just going to take you longer, right? But in theory, angle Q2 should just be the 180 minus the 69.4, which is what?
Oh, 1.7.
All right, good. That's what I got to. Okay. So this might not be so bad after all, right? Is there a short way to do the top angle too?
180 minus.
That's part's the same, right? Same as step 2 in the other one, right? I'm gonna go 180. Here, I'll write it down. Angle R2 is gonna equal the 180 minus the 110.6 minus the 42.6 that's in the question. So angle R2 should equal 26.8. Okay, and 3. We're going to solve for that red R2. How do I do that? That I don't know if you could, there's a shortcut for. I think you just got to use sine law. Okay, so we're just going to go sine of, same as before, I would use the information that's been provided to you in the question, just to avoid, maybe you made a little silly subtraction mistake, I don't know, is equal to sine of R2, which we just found to be 26.8, over R2. And so when I go to solve, R2 is going to equal, here, I'll write it out just so you got it. So I actually don't think, like, the information provided to you at the beginning of the question, I don't think can change. Which means what? If the information that starts the question doesn't change, then what must be true about the process by which we're solving? That's not going to change either. So what is this now? This is a reproduction activity, right? It's, can I reproduce these steps? Because there's no way for me to be able to do this question without providing you the same information at the beginning of the question. Right? The only hard part is making a conclusion as to how many triangles there are based on the front side of this lesson today. 1, none, or 2. And which one do you think I'm going to ask you on the test? Probably the most interesting one, which would be the one we just finished doing.
Probably gonna ask the 0 just to trick us.
Well, I mean, I could do that too, right?